How's it going, everyone? Welcome. Larry Gonzalez here. And today, let's going to make a quick recap of what is this video and particularly book about when we try to here understand now what JavaScript is, right? So based on Kyle Simpson, as a way to now understand the entire story of how do we get here with JavaScript, and therefore then dive deep into the chapter two, which is actually is to understand and to survey is JavaScript, right? So what are your assumptions about it, right? So this chapter one we talk about is the JavaScript. So since the name in itself and also the, this particular book, the You Don't Know JS Yet, is uh, for those developers that they want to dive deep into the JavaScript language per se, one, and second that they of course have some experience on top of that, and since you are part of this group, okay, then understand a little bit of the JavaScript, right? So first and first, where the name come from, which is part of the marketing, is an artifact of the marketing shenanigans. Yep. So it is an artifact of the marketing shenanigans, where the idea is that because this language that was created by Brandon H. when he worked at Netscape, the first commercial browser, and the code name that he gave to this scripting language was um, Mocha, and internally the company know this language as LiveScript, right? So as the year or since the marketing team wants to position this product for an audience that are familiar with Java, but in contrast of this heavy, well-known language, they want to provide an alternative, lightweight to that, which is interesting because it now grows into what we know as this huge, gigantic frameworks on top of that, and so on and so forth, right? But the thing here is that with JavaScript, right, that's where the name comes from. Is just that those who comes to this language, they are assuming that you are quite familiar with Java or C syntax, all right? So for example, like block, and because of this, you must well known uh, how the language actually works behind the scenes. So this is great for if you already have a background on those language, and I think this is quite interesting and important for anyone who wants to start to define or make JavaScript as to the to understand JavaScript as a career around this, okay, and to provide now features on top of that and so on and so forth. Since the language in itself, it is now the language specification. It is it is taken care by the TC39 commit, which is a group of people that come from a variety of industries uh, that are web related industry, such as browser makers or device makers, such as Samsung, for example. And because this particular language, the trademark is owned by Oracle via a series of acquisitions, where it all started with Netscape, with AOL acquisition, So AOL acquired Netscape in 1998, and then now AOL was acquired by Microsystems Some, and that company was acquired after the dot-com bubble in 2009 by Oracle, and now that's what we have. So that's why Oracle, despite that it never has enforced the trademark, and quite honestly, it's quite hard to do so. So no matter how you call the language, whether it's ECMAScript, which is the technical specification, or JavaScript, or ES6, or ES, the year of the specifications, uh, it all boils down to JavaScript, not Java, right? So JavaScript is like ham for it. So JavaScript is to Java like ham is to hamster, right? And this is quite interesting, that analogy, because actually it summarizes a lot of this. So Jeremy Keith uh, make that assumption here, and I find out very very interesting. you know, uh, so yeah, he is actually is an Irish web developer, right? He's a writer, speaker, and a musician. He authored popular blog and has written several books, including Dumb Scripting, a guide to web design with JavaScript, and the document object model. He curated the Deconstruct conference and co-founded Clear, Clear, Clear Left in 2005 with Andy Budd and Richard Reuter. So books, you get Dumb Scripting, Bulletproof Ajax, HTML5 for Web Designer, Resilient Web Designer, and Going Offline, right? Keith's book, Going Offline, is a guide to service worker. Uh, it was published on 24 April 2018. And I think that's quite interesting, this particularly book, especially when talking of web workers and that kind of thing. Because when you think, yeah, you need to be more specific about this, you know. So going offline. So yeah, so he is a public speaker, right? It's interesting because that actually is not. So that actually is not. I think he mainly do is private contribution. All right, or maybe not. Who knows? But anyway, uh, a modern web dev agency focused on TypeScript and AI. So good, 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 good. Awesome, awesome. So it's him, right? Jeremy Keith. And now he is the founder of Clear Left, right? Good. That's quite interesting. Uh, yeah. So based on this, we also look at the language specification as a way to now understand is who are the responsible for ensure the standards and the functionality from the language, right? In for the documentation as well, and that is the TC39 group. All right. So this is a couple fellas that come from different web-related industries and companies that sometimes those company so they receive some sort of compensations to be part of this team, and some of those companies sometimes provide all the logistic for hosting the event. Now the crucial here is that this TC39 commit that they now promote some proposals or champions that are candidates that needs to go up. They need to go up to the top by passing through this stage from 0 to 4, because we as programmers started to count from 0. We went through that, okay? And the point is that since uh, previous to this, everybody can now and is encouraged to be part of the discussion about what's the proposal or the champion that's going to be up into the spec, uh, which is known as pre-stage 0, but only those who can get into that meeting, which is run by each month after, are those uh, are those who gonna be on the final stage, or gonna be those they're gonna be on this stage proposals, which is the only source of truth. So once a proposal or a champions goes way up to the top, from stage 0 to 4, right, which is something that can take weeks, months, or even years, now it is released that. So because some browsers and some JavaScript engine implementations, they needs to uh, face the reality of the web and also follow the spec. Sometimes they can is decide to ditch those recommendations or not implement that. Why is that? So there are also some couple examples that has passed in the couple decades. So for example, with the method called uh, includes, which is just something that we know now. We The TC39 wants to use this as, so the wants to use is the contain, not the includes. But because there is a particular library out there that was using that, so they have to ditch that and rename that, right? And the other, which is more uh, funny and chaotic, which was a dramatic in, in, in comical situation, known as this Mushgate, where the TC39 wants to implement now the flatten as a way to take an array and flattening or remove the dimensions to keep, and you are going to indicate how many dimensions you want to this collections will be, all right? So because there is a particular library in Germany that was using the name flattening exactly for arrays, and not only that, because you can perhaps override that behavior, but that uh, li- that library not only is modifying the behavior of the how do you call it, of the implementation, but also is doing some dumb manipulations. So that's not what you want to do, especially if you want to override a behavior like that. So that's why now they went back uh, to the draw table, sort of speaking, and they now to rename that to call that flat. So this is why in array we have this thing called flat, right? So instead of flattening, we have is flat. But the thing here is what it's doing is now flattening that, right? Experimental. This is an experimental technology here, but I no exactly. It's widely available. All right. The thing here is that this only flats per level. You can also indicate now is the depth of how you want to flatten it. But again, it's known as flat. So all of this is just to understand these small nuances that, despite that sometimes the TC39 actually roll back some of the changes, but most of the time what they say is the law. And most JavaScript engines most stick to the law. Those who are not do the reality of the web. There's a particularly appends on the spec that actually describe what is this particularly behavior, this mismatch behavior. And speaking of behaviors and mismatch, since now we can run, we can have the same behavior, aka we can run our JavaScript engines in different environments, the browser, the web, the server, the light bulbs and robots and yada yada. It is important to know that no matter where you can run this, there is a particular mismatch from their mental model, because each one of those environments now provides specific methods that you can work on. So for example, in the case of the browser, you have now alert, also console, as well as fetch, get current location, and get user media. Now in the server you have is the console, but you don't have the alert, but you have is now written file, synchronous or asynchronous, or fetch as well. Uh, so the idea is to recognize that, and because we have now this many environments we can run our JavaScript code, the reality, in the only reality that matter is the web. So because the web uh, is what the JavaScript spec actually is or follows, not all JavaScript is on the web. So that mean is that, as I mentioned before, so all of these different environments that we can run actually are very specific in that regard. Also, that because the code that we're going to write, or that we're gonna write, or since we're gonna write code, and this code are gonna be using is the latest features, and we need to provide some compatibility to older browsers and older that runs in different uh, machines. So this is known as backward compatibility. So because the TC39 say we don't want to break the web, so this is known as backward compatibility. Unlike the HTML or CSS, that is forward compatibility. So some applications written in 2000, and if they not receive any updates, is less likely to be run on the on current browsers like 2025, especially HTML and CSS, right? So because this backward compatibility needs to be done traditionally here, this is done by Babel, which is a transpiler. We're gonna see what a transpiler means and why useful is this concept. So a transpiler is this code that we need to code target that we need to now is somehow transform into those particularly available browsers. So we need to also is use something called as polyfill that allow us is to define well what is the specific features that are not supported by other browsers, that we need to provide some shins and actually allow us to use that behavior. All right. Now, because in JavaScript we can write code in different patterns, language. Okay, so you have now uh, the procedural. You have now object-oriented programming and functional programming, where the object-oriented programming says, let's going to now write our applications in this unit called class that is going to has the data and its functionality together, right, in one single unit. Whereas in functional, you say, hey, let's go to now create our function, which are pure, which means that when you call that function, it won't crash in your application in an unexpected way. All right, it won't modify the state of the application in an unexpected way. So if you want to now a new calculation or a new desired state, you just only call that function to generate is a new desired state, a new pure function. So again, the idea here is to understand that JavaScript now is multi-paradigm. It follows these three particular methods, okay, or approach in which programmers approach to a problem and a solution, right? So with that, then by the time that we look at how the language actually works, or how the JavaScript engine actually transform the script language into something that can be understood by machines, so binary code, because JavaScript code is not an interpreted language as most people would like to think. In fact, is a parse language. What does it mean is that historically there has been a lot of developers, or the history of computing has seen interpreted language as inferior due performance reasons. Because unlike compile, where those language now compile the code, which means that perform error analysis and actually output a portable binary executable applications ready to be distributed in those particular architectures, all right? Whether it is, so for example, like IPA, which is only for iOS, or .app, or in the case of Android, like .app APK, or in Windows you have the .exe or .msi, and on how do you call it? And on yeah, and on yeah, how do you call it? And on and in Linux distro, for example, like you have now Jump for Fedora distributions, or you have .dem for Debian, so on and so forth. You know, but the thing here is that that is now an optimized uh, uh, that is an optimized version of this instead of instruction that sits on disk, and when you execute that, now they load by the OS into the main memory and executed by the processor, and they create now a process. But again, the thing is that it's optimized, and rather than debate that which one is better or not, I think the truth of this of for this matter is that how those compilers or interpreters actually manage errors. So, for example, if you're in an interpreted language that it needs to evaluate each one of those statements, All right. So let's say if you have a program that start from line 1 and then at line 5 is where you have some particular error, it needs to go through all of that until it find the error. It can be a syntax error, it can be a reference error, you know, but it needs to wait until that. Whereas in compiled languages, what happens is that it's going to take the entire script, okay, or the entire set of instructions, and it's gonna convert that into something called as the abstract syntax tree. In compiler theory, there is this process of tokenization, and the tokenization as a way now to put the relevant tokens of the language, as well as there is values. So, for example, operators, keywords. You can think of this like putting into different buckets meaningful words on the dictionary, all right, as well as their values. So once you get this through the tokenization, now it's create the thing called as the abstract syntax tree, or the parsing, the syntactic analysis. This part is something that is go and detect if there any syntax error there. The thing here is that by the time that uh, is tokenized, and that code is now transformed into this abstract syntax tree, usually it also now generate a binary optimized version, portable, of your code, which is ready for for the machine to be executed. So because JavaScript actually is a parsed language, and you can check that by anytime that you make some syntax error, all right, you use a parenthesis, or you use a single quote or a double quote, it actually is gonna use that against you. It is actually going to tell you something went wrong. All right, this is the the reality check for the language to say this is what JavaScript is doing. So JavaScript is now perform a parse, right? Doing this syntax analysis, and then those JavaScript engines implementations, once they get that, it will now take that abstract syntax tree and convert that into some intermediary representation of binary code that will be passed by a compiler. All of this live inside of the JavaScript engine, all right, to refine and optimize the code, and then is when the JavaScript code is executed. So to be more friendly, okay, or to boil down for you, so when your JavaScript code leaves the IDE, it is transpiled into a specific target that is quite different to the current code, right? It is transpiled to a specific version of the code that is available across different browsers, and then bundle up to the ready to be distributed. So once the JavaScript engines receive that, it will now parse that, meaning creating is the abstract syntax tree, and then it create now this intermediate representation of your code that is going to be passed down to the compiler, or just-in-time compilations, to further refinements and optimizations, and then is when the code is executed by the JavaScript engine, right? So this particular process is quite important to understand because if you want to now understand the WebAssembly, what this things is actually doing, well, we say, all right, uh, the idea of the WebAssembly, it all starts with the concerns about how fast can the JavaScript engine parse the language and execute the code. It's because of this. So there has been so there was an attempt to prove that JavaScript actually can run a particular game. So they pour the engineers at Mozilla in 2013 actually pour that they pour that code. They pour an Unreal game into the JavaScript engine that runs at full 60 FPS, and they doing behind the scene is now so the code that they wrote, it was quite different of how we normally write JavaScript code, but they are now adding some notations to the engine to perform some optimizations behind the scenes. So this is what's the first attempt, known as the ASM.js, and then now, as the year by, in again the engineers at Mozilla now create this WebAssembly, where the idea is to act as a target compiler, all right, for any language, all right, that it was initially used to target is code in JavaScript and then compile, and then compile for the JavaScript engines by skipping is the parsing phase. And this is something that now the WebAssembly is on the current stage, all right. So WebAssembly is the effort that the community actually say to make this. So it's an effort to compile, to act as a universal compiler target. So giving a particular language, all right, I want to now target into a specific output, target the compilation here. So I think that's quite interesting. So instead of using, for example, GCC to run code in a specific architecture, you can now use WebAssembly. So by passing now is Go or Ruby or Java, and then it's going to compile at a specific target, right? Whether it's on architectures x86 architectures or the MIPS architecture or ARM architectures, but that's the whole point of this. Okay, so WebAssembly is not an attempt to, as a lot of people might say, is not an attempt to replace JavaScript. Is to now act as this universal compiler target. So I think that this is because this course is not about WebAssembly. I find that out that is yet relevant for us to at least know or to have a vision of what this things is all about. Okay? So with that, okay, in that another thing that we need to understand is that not all JavaScript environments are JavaScript. despite that the console actually you can think of this like a JavaScript environment, but the thing is that they don't act as a true JavaScript environment. So for example is when you are using the strict mode is being used uh, through the entire console season. That's one. There was another topic here for that to me was interesting. That is, uh, oh, that the global objects, all right? So anytime that you add now a var or a functions, those declarations actually it creates now a a global variable in the window object, which is something that is not happened uh, in JavaScript environments. All right. So again, I just mentioned is this two one is just to understand, and the other is the how hosting is working. And I love this. The other is that how hosting works across multiple line entries. All right. So in any case, the point of this is to recognize is that, and the TLDR is that, well, at the end of the day, JavaScript, all right, it's an implementation of the ECMAScript standards. Uh, exactly. So JavaScript is an implementation of the ECMAScript standard, ECMA 262, all right, which is guided by the TC39 commit and hosted by ECMA, which you can run that in different environments. The browser, the server is multi-pattern, uh, which you can now use different approach, whether it's procedure of Unity programming, NFP. It is a compile language, so to speaking, right? We can think of this as a compile language. Specifically, JavaScript is a parse language, okay? So meaning that including the JavaScript engine process and verify a program before it executed, okay? And with that, we define what JavaScript it is. So now, here, the survey with GS is this. So, we mentioned when we look that each file is a program. I actually take my notes here. So each file is a program. So because almost every website that you load code, all right? So almost every website that you load code, you can think that your JavaScript code act as a single program. But the thing here is that no matter how many script you load to your website or your web app, you might think that your programs act as a single program, but that's not. But JavaScript see it different. JavaScript see it as a separate program. So each file, each script that you're loading is a separate program, and the reason this is matter is primarily around error handling. Right? So the reason this matter is primarily around error handling. Since JavaScript treats file as programs, one file one file may fail during parser and execution. Okay, this will not necessarily will prevent the next file to exactly. This will not necessarily prevent the next file to be processed. However, it make your web app in an in a partially operated. Exactly. It will make the overall application uh, only partially operable operatable. Mhm. At best. Okay, so it is important to ensure that each file works properly, and that to whatever extent possible, so they handle failures in other files as graceful as possible. It may surprise you to consider separate.js file as a separate JavaScript program. It might be tempting to think that all of those programs, as I mentioned before, act as a single one. But JavaScript sees this different. JavaScript see each one of those scripts uh, as a program, or each file as a program. And it makes a lot of sense. So for a design perspective, it makes a lot of sense, because if you see each one of those files as a separate program, when one of them failed, it won't interrupt the parsing or execution of the next one. However, the downside is that your applications will operate partially, right? At best. Mhm. So it is important to ensure that each file works properly in whatever extent possible, and if they now depend on one another, handle those failures gracefully. So it may surprise you to consider separate JavaScript file as a separate JavaScript programs from the perspective of your usage of application. It sure seems like one big program. That's because the execution of the applications allow these individual programs to cooperate and act as one program, right? That's because the execution of the application allow these individual programs to cooperate and act as one program. Exactly, exactly. But that's because exactly it may surprise you to consider separate JavaScript files as a separate program from the perspective of your usage as an application. It sure seems like a big program. That's because execution of the applications allow the individual programs to cooperate and act as one. Exactly. So that's because it's the execution of the application, which is made of several files, allow these individual programs to cooperate as a single program. And the only way that multiple standalone JavaScript files act as a single program is by sharing their state and access to their public functionality via the global scope. Via the global scope. So they mix together in this global scope name. So at runtime, they act as a whole. But it's not at parsing, but at runtime, if you, for example, have several of these files that share, if you have several of these files that are sharing is the global space, the global scope, right? Exactly. If you have these several, if you have these several files, so if you have these several files, so if you have, so the only way that uh, those uh, single files actually act as a single program if they share the same global, if they share the same states via or the public, all right, and access to their public functionality via the state, via the global state, all right. So they mix together in this global namespace, but they act as runtime like a single program because they have access to this global state. Okay, that makes a lot of sense. Since EX6, JavaScript has also supported a model format in addition to the typical standalone JavaScript program format. Models are also file-based. Interesting. So, for example, if you have an import, if you have now a script if you have a script type model, all right, all this code is treated as a single model, aka as a single file. So you wouldn't typically think about a model, a collection of a state, and publicly exposed methods to operate on that state as a standalone program. JavaScript does, in fact, still treat each model separately, similar to how global scope allows standalone files to mix together at runtime. Importing a model into another model allow runtime interoperations between them. So regardless of which code organization pattern and loading mechanism is used for a file, standalone or model, you should still think of each file as its own mini program here. So no matter which particular organization pattern and loading mechanism here, all right. So no matter which one of them, an organization pattern via models, an organization patterns, or a loading mechanism uh, is used for a file, whether it is a standalone script or a model, all right, you should still think that each file as a mini program, which may then cooperate with other mini programs to perform the function of your overall applications. But that's interesting. Why this is important? Because mm, 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 mm. Perhaps you're going to okay, okay, all right. So the other is values. The most fundamental unit of information in a program is a value. Values are data, and they are how the programs maintain states. Values come in two forms, into primitive and non-objects. So values are embedded in programs using literals. Greetings, my name is Kyle. In this program, the value, my name is Kyle, is a primitive string literal. Strings are ordered collections of characters, usually used to represent word and sentence. I use a double quote character to delimit, surround, separate, and define the string value, but I could have used a single quote character as well. The choice of which quote character is entirely stylistic. The important thing for the sake of the code readability and maintainability is to pick one and use it consistently throughout the program. Another option to delimit a string literal is to use the backtick character. However, this choice is not merely stylistic. There is a behavioral difference as well considered. Oh, of course, exactly. So it is this, my first name, my first name. Assuming this program has already defined a variable first name, if you use this is called as interpolation. The backtick delimited string can be used without including interpolate expression, but that defeats the whole purpose of the alternative string literal syntax, as it is. I am confusing. I am confusing you by omitting interpolation. The better approach is to use double or single. Again, pick one and stick to it for a string unless you need interpolation. Reserve only for a string that will include interpolation expression. Other than string, JavaScript programs often contains other primitive literal values such as booleans and numbers. While false will represent a loop type a way to represent operations while its condition is true. Why this is important? Especially talking about values. It's the most fundamental unit of information. Okay. Unit. This word is going to be repeated across several systems. Alright? So the most fundamental unit of information in a program is a value. So, for example, when you hear about threads, that they are unit of execution, it means that somebody actually are defining that. In the case of the threads, is the OS, and in the case of the unit, is defined by the language. Okay, so the units which are defined by the language is, well, a primitive and an object. All right. Here we are describing is the strings as well as the boolean, right? The number is, as you may know, an approximation of the mathematical p to the first 6 digits rather than embedded such as value. However, you will typically use the predefined math.pi value for that purpose. Another variation of number is the big int, which is something that I'm quite familiar. It is like it allows you to store integers bigger than the max safe representation, which is the so for example here the max safe representation here is something like 2 power 12, yeah, to almost 24 minus 1, but again it's not gonna do that. But the point of this is that it allows you to represent is a number that is greater than this. All right. In fact, yes, a number that is greater than this. I think if I use the max safe, say number max value, like this. All right, this is the maximal number that it can be represent. And why this is important? Well, because for bigger numbers, and you want to do some operations on that, because the way how those numbers are internally represented, and perhaps it go beyond the scope of today's video, but I just wanted to make sure that they have a limit, and this is the limit that they have. Anything that go beyond that, you still can use that. All right. So for example, you can say is the max safe integer, all right, which is this. This max safe integer is the maximal value that you can operate on that when you do some mathematical operations. Because what happens when you do this? Exactly. And if you want to understand more about that, you can take a look at the the precisions of those numbers, okay? Where the idea is to understand that there are certain numbers that are quite hard to represent. They are not accurate representation of that. So for example, 1 divided by 3 is something that you can accurately represent that. So how do you now store a value that is infinite in a finite memory? So because of that, there are some round errors that happen, and this is the reason why when you try to do this kind of operations here, that's why it's not an accurate representation of that. So because of that, we can now for example, transform this particular number into a big int, all right, and transform that as it is. You can say the way to transform this is like this, right? And then you transform that into a big int, all right? So you can also either do this. It will actually, for this particular number, actually works well, all right? But anything that go beyond that, again, you risk yourself to not being precise. So, but in any case, and the way how you can fix that is by moving is the decimal points from that. So perform the entire operation. Perform the entire operations in the as an integer, right? And then move to the right the up to the cent. So you can actually, this is how Stripe actually works with numbers. Anyway, so here we are. We use 1 for elements in the second position. And again, that is not exclusively to JavaScript. That is exclusively for all languages that actually use that implementation, that internal representation. So yeah, that's my bending. That's quite interesting. All right. So yeah, we use 1 of the element in the second position instead of 2. JavaScript array indexes are 0 base, is the first position. In addition to strings, numbers, and booleans, 2 other primitive values in JavaScript programs are null and undefined. While there are differences between them, some historic and some contemporary, for the most part, both values serve the purpose of indicating emptiness or absence of values. So many developers prefer to treat them both consistently. In this fashion, which is to say that values are assumed to be indistinguishable if care is taken. This is often possible. However, it is safe and best to use only undefined as a single empty value, even though null seems attractive in that it is shortened to type. The final primitive value to be aware of is symbol. Okay, however, it is safest and best to use only undefined as a single empty value, even though null seems attractive and it is shortened to type. The final primitive value to be aware of is symbol, which is a special purpose value that behave as a hidden, unguessable value. Symbols are almost exclusively used as a special key on an object. And you won't encounter the direct use of symbols very often in typical JavaScript programs. They mostly used in low-level code such as in libraries and frameworks, array and objects. Beside primitive, the other value type in JavaScript is an object value. As I mentioned earlier, arrays are a special type of object that comprise an ordered and numerically indexed list of data, right? So we get this, name length, name 0, name 1. JavaScript arrays can hold any value type, either primitive or object, as well as we'll see toward the end of the chapter 3, even functions are values that can be held in an array and object. Exactly, you can have a collections of functions. Functions like arrays are a special kind, aka subtype of objects. We'll cover function in a more detail in a bit. Objects are more general and unordered key collections of any various values. In other words, you access the element by string locations named aka key or a property rather than by its numeric position. For example, you get this, and the way to have access to that properties is through a key, which is, hey, the key is first. Here's me represent an object and the first represent the name of a location of information in that object. Value collection. Another syntax option that access information in an object by its property slash key, use the square bracket, this one. Such as me first. Value type determination. For distinguished values, the type of operators tells you it is built-in type, if primitive, or objects otherwise. Exactly. This is to understand this specific thing as it is. Like this. The type null unfortunately return an object instead of the expected null. Also, type of return the specific function for function but not the expected array for array. Exactly. Converting from one value type to another, such as from string to number, is refers to in JavaScript as coercion. Exactly. The process of converting here is known as coercion. From one value type to another. We'll cover this in a more detail, something that I'm quite familiar to that. But it wouldn't harm to do that. Primitive values and object values behave differently when they are assigned or passed around. And we'll cover this detail in Appendix 8, values versus reference. Declaring and using variables. To be explicit about something that may not have been obvious in this previous section, in JavaScript programs, values can either appear as literal values, as many of the preceding examples illustrate, or they can be held in variables. Think of variables as just containers for values. Okay. Think as variable as just container for values. So you can think of this as a bucket. Okay? So I got this bucket, and so on and so forth. So variables have to be declared or created to be used. Exactly. So variables has to be declared or created to be used. There are various syntax forms that declare variables, aka identifiers, and each form has different implied behaviors. For example, consider the var statement. So here you are now is creating a variable, a container of a variable, and then assign it to. Or here, you just only creating is a variable, a container, without anything. The var keyword declares a variable to be used in that part of the program, and optionally allow an initial assignment of a value. Another similar keyword is let. Exactly. They behave different. The let keyword has some difference to var, with the most obvious being that let allows a more limited access to the variable than var. This is called block scoping, as opposed to regular or function scoping. So variables are now regular or function scoping, and lets is block scoping, right? So consider this: var adult is equal to true. So is adult is this my name? I'm gonna create this variable here, and is this, and this is a secret. Console.log my name, right? An error console.log age. So the attempt to access to the outside of this statement result in an error because age was block scope to the if, whereas my name was not. So block scoping is very useful for limiting how widespread variables declarations are in our programs. So how this container can be hacked access to, which helps prevent additional overlaps of their name. But var is still useful in that it communicates this variable will be seen by wider scope or the whole function. Both declaration forms can be appropriate in any given part of a program, depending on the circumstances. Note: it is very common to suggest that var should be avoided in favor of let or cons, generally because of perceived confusion over how the scoping behavior of var has worked since the beginning of JavaScript. I believe this is the overly restrictive advice and ultimately unhelpful. It is assuming you are unable to learn and use feature properly in combination with other features. I believe you can and should learn any feature available and use them where appropriate. A third declaration form is cons. It is like let but has additional limitation. That it must be given a value at the moment it is declared, and it cannot be reassigned or redeclared. Consider this: my birthday here is true, the age is 39, and then you got it's my birthday, age plus 1, right? But then you want to switch that to false. You can. Cons declares variables are not unchangeable and they just cannot be reassigned. It is ill-advised to use cons with object values because those values can still be changed even though the variable can be reassigned. This leads to potential confusion down the line, so I think it is wise to avoid situations like when you have this, a collection of two, and then you get this, right? And actor 2, Tom Cruise, and then you want to now clean all of those actors, right? Unfortunately, it say this, right? Unfortunately, it say this because those values can still be changed even though the variable can be reassigned. This leads to potential confusion down the line, so I think it is wise to avoid situations like this. The best semantic use account is where you can simply you have a simple primitive value that you want to give a useful name to, such as using my birthday instead of true. This makes programs easy to read. If you stick to using cons only with primitive values, you avoid any confusion of reassignment, not allowed, versus mutations, which is allowed. That's the best, safest, and way to use cons. Exactly. It doesn't allow you to reassign this value. It doesn't allow you to redeclare or reassign primitive values. However, objects you do. Besides var, lets, and cons, there are other syntactic forms that declare identifier variables. In various scope, for examples, you get this. Function hello my name, console log and hello my name. The identifier hello is created in the outer scope, and it is also automatically associated to that so that it references the function. But the name parameter my name is created only inside the function and thus is only accessible inside that function scope. Hello by and my name generally behave as var declared. Another syntax that declares a variable is a catch clause. Okay. The error is a block scope variable that exists only inside the catch, as it has been declared with the let. So it's describing is this huge overview of declaring and using variables. The value types, alright, something that I'm quite familiar, alright. So each file is a program. You have value, which is the unit of is the most important unit of information in Claude is one of them, right? The values, as well as declaring and using variables, all right? And then we have now function. The word function has a variety of meaning in programming. For example, in the world of functional programming, function has a precise mathematical definition and it implies a strict set of rules to abide by. In JavaScript, we should consider functions to take the broader meaning of another related term, procedure. A procedure is a collection of a statement that can involve one or more times and maybe provide some inputs and may give back one or more outputs, right? Okay, so it's a collection of a statements that it can uh, may, maybe provide some inputs, okay, they can invoke one or more times, maybe provide some inputs and may give back one or more outputs. So it's not deterministic. From the early days of JavaScript, function definition looked like awesome function, cool things, returns amazing stuff. This is called a function declaration because it appears as a statement by itself, not as an expression in another statement. The association between the identifier as awesome function and the function value happens during the compile phase of the code before that code is executed. In contrast to a function declaration statement, a function expression can be defined and assigned like this. Exactly. This is known as functions expressions. And again, the term expression means that they're going to produce a value. All right? That's what they call here. This function is an expression that is assigned to a variable, awesome functions, different from the function declaration form. A function expression is not associated with its identifier until the statement during runtime. It is extremely important to note that in JavaScript, functions are values that can be assigned as shown in this snippet. Functions are values that can be assigned and pass around that. You know, exactly. So functions now are values that can be assigned. You can think of this as a container, as a variable, that can be now shared across different places. Interesting. In fact, JavaScript functions are a special type of object value types. Not all languages treat functions as values. Exactly. Not all languages treat functions as value, but it's essential for a language to support the functional programming pattern as JavaScript does. JavaScript function can receive parameter input, but this is interesting because that makes a lot of sense. So if we know that variables is the most important unit of information, and we can think of this variable as a bucket or as a container that we can now put is primitive or objects, all right? And depend when you will define those containers, we can have access to those containers, or they can spread across your application at different locations, right? Whether it's per functions or whether it's per function or per block, okay? Exactly, whether it's per function or per block. That's interesting. And because now functions are values that we can assign to these variables, they can not only behave these variables as like tokens, all right, as now this set of instructions that we can now pass here or there on some place, right? That's powerful. That's powerful. And this concept is what makes the possibility of thunk, bro. Interesting. Interesting. For a concept and a definition is when the creativity kicks in, bro. Mm-hmm. Interesting. So this function is an expression that, okay, so it is extremely important that to understand that JavaScript function can receive parameter inputs. Exactly. In greetings with Kyle. In this snippet, my name is called a parameter, which acts as a local variable inside the function. Functions can be defined to receive any number of parameters. In this snippet, my name is called as a parameter, which acts as a local variable inside of the function. Exactly, act as a local variable inside of the function. And functions can be defined to receive any number of parameters from none upward as you see fit. Each parameter is assigned the argument value that you pass in that position. Kyle here on the call. Functions can also return value using the return keyword. Exactly. So for example, like this. This becomes now a function call that is gonna return you is the computation of that. So you can only return a single function. You can only return a single value, but if you have more values to return, you can wrap them up into a single object array. Since functions are valued, they can be assigned as property on object. Mm-hmm. Since functions are values, they can be assigned as property. Since functions are valued, they can be assigned as since functions are values, they can be assigned as properties on objects. Exactly. So they can be as okay, okay, okay. Since functions are values, they can be assigned as properties on objects. So you can have this. All right. Okay. So at the end of the day, they are values. Okay. So they are values. The question and the answer. What to say dot greeting. In this snippet, reference to the three functions, greeting, question, and answers, are included in the object held by what to say. Each function can be called by accessing the property to retrieve the function reference value. Compare this straightforward style of defining functions on an object to the more sophisticated class syntax. Wait, what? Each function can be called by accessing the property to retrieve the function reference value. Mm-hmm. So compare this straightforward style of defining functions on an object to the more sophisticated class syntax discussed later in this chapter. There are many varied forms that functions takes in JavaScript. We dig into this variation in Appendix A. So many functions form. Mm-hmm. And then you have another comparison. Okay, I think I'm gonna leave that like that because this is quite long and verbose. How we organize in JavaScript using the classes, class inheritance, model. Mm-hmm. Mm-hmm. And the rabbit hole deepens. As promised, at the top of this chapter, we just glance over the wide surface area of the main part of the JavaScript language. You hate your head may still be spinning, but that's entirely nature after such a fire hose of information. Even with just this brief survey of JavaScript, we cover hinted a ton of detail you should carefully consider and ensure you are comfortable with a series when I suggest reread this chapter maybe several times. In the next chapter, we're going to dig much deeper into some important aspect of how JavaScript works at its core. But before you follow that rabbit hole deeper, make sure you have taken adequate time to fully digest what we have just covered here. And then in the chapter 3, dig into the roots of JavaScript. And then you have the iteration, consuming iterators, iterables, closures, the this keyword, and prototypes. This revisited and asking why. And then you have now the chapter 4. You don't know GS yet, get started second edition, the bigger picture. Okay. Pillar 1, scope and closure. Okay, scope and closures. Prototype, type and cohesions with the grain. Okay. Okay, so that'll be all for this video. Take care. Bye bye.